guys, welcome to Chemchris TV, and in today's video I want to teach you how to draw label structure. So I want to walk you through 5 simple steps and how you can draw label structure. So make sure you stay to the end of this video. And if you are not subscribed to this channel, please subscribe, hit the subscribe button now so you're not going to miss out any video content drop on this channel. So let's get started. To draw label structure, you must know 4 different things. First, you have to know the word valence electron. 2, you have to know the octet electron. Then 3, you have to know what the bonding electron and what non-bonding electron, which I've done in my first video on Lewis structure. So that was what just a beginner video to explain the simple concept and how chemical bonding works. So if you have not watched that video, please I will recommend that video for you. It's at the description below. Go and watch that video now because it's actually going to help you, right? But if you have done that, good, you can start with. So the first you want to do when it comes to Lewis structure, the first tool is what? Calculate the total valence electron in the molecule. Now let's start with this guy here. So if you have something like NH3, now how do you calculate the valence electron? Remember, I told you that valence electron is what? Is the group number, right? The group number or the atoms electron. So each element in the periodic table have their own various group, and that group means what? The valence electron. So here we have nitrogen and then what? And hydrogen. So what is the valence electron for the molecule? V means what? Valence electron. So now nitrogen is in group 5 times what? 1. How do we get 1? Is what? Total numbers of atoms in the molecule. Nitrogen is 1, then the valence electron is 5 plus hydrogen is what? 1 times what? 3, right? So it will be 5 plus what? 3, which is what? 8 valence what? Electron. So that's how to do it. The next thing I want us to do is what? H2O, right? So what is the valence electron? Now the valence electron here, you have hydrogen is in group 1 and is having how many here? You have how many hydrogen here? 2. So it will be 1 times 2 plus what? Oxygen is what? Is in group 6, 6 times 1, right? It will be 2 plus 6, going to about 8 valence what? Electron. So the next one I want us to look at is what? XO2. So now what is my valence electron here? Here we have 6 times 1 because sulfur is what? Is in group 6 plus 6 times 2, right? So if you do that, 6 plus 6 times 2 is what? 12. Here I want to have what? 18 what? Valence what? Electron, right? Now what about if you have what? NO2, right? Minus NO2 what? Minus. Good. Now whenever there is what? A minus sign here, I want to what? Add the total charge to the what? Valence electron. Whenever there's what? There's a minus here. So my valence electron here going to be what? Nitrogen what? Is equal 5 times what? 1, right? Plus what? 6 times 2. Now here we have minus 1, so it's going to be plus 1. 5 plus 12 plus 1 is going to give me what? 18, right? Going to be what? 18 what? Valence what? Electron. So if you should have something like this, NH4 plus. Now here's what is a positive sign. Now whenever you have a positive sign, you're going to subtract from the total valence electron. But whenever you have a negative sign, you have to add to the total valence electron. So here you have valence electron here. It's going to be what? 5 times 1 plus what? 1 times 4 minus what? 1. So here we have 5 plus 4 minus 1. It's going to be what? 8 valence what? Electron. Right? So the next thing you are going to look at. So I would like you all to try some SO3 2 minus. So go ahead and pause the video, then calculate some for me. Okay, now let's do it together. Valence electron here we have what? 6 times 1, right? Plus 6 times 3 plus what? 2. Why is it plus 2? Because here we have what? Minus 2. So I'm adding them together. So 6 plus 18 plus 2, 20 what? 6. 26 what? Valence what? Electron. Right? So this is how to draw to calculate the total valence electron of any what? Molecule, right? So now let's move to what? Second step and third step. Step 2 and step 3 go along with each other, right? So I like you all to pay very close attention. So now what is step 2? Step 2 is what? Place this least negative element as the central what? Atom, right? Why the rest as what? Side atom. I'm going to teach you that. I'm going to do question on that. Then next thing, we use step 3. Step 3 is what? Connect the side atom to the central atom with a single bond and calculate what the remaining electrons. So now let me teach you how to do that. And let me show you how to do that. Now let us take this one again. NH3. Remember, we have to calculate the total valence electron, which is what? VE, right? So we're going to be 5 times 1, right? Plus what? 1 times 2, right? We're going to be what? 8 valence electrons. So that is step 1. Now what is step 2? Now in step 2, now hydrogen and fluorine can't be the central atom. And there's a reason for that. Fluorine is what? Is the most electronegative element in the periodic table. So it cannot be what? The central atom. Then hydrogen can only have a single bond, right? So nitrogen is not going to be what? My central atom. So nitrogen is the central atom. Then we connected towards hydrogen. Hydrogen what? Hydrogen. So hydrogen what? Central atom. That was step what? 2. Step 3 says you should do what? Connect each of them to what? A central atom with a single bond. Right? Now remember, each bond represents what? 2 electrons, right? So here we have 2 electrons, 2 electrons, 2 electrons. So that is, I've used 6 electrons. So out of my 8 electrons, I've used what? 6 electrons, right? So now what? Remaining electron is going to be what? 8 minus 6, which is what? 2, right? So we are going to use what is step 4 and what is step 5. I'm going to what? Step 4 and what? Step 5. So now let's do on that one here. If you have something like this, SO2. Now what is valence electron here? My valence electron here is what? 6 times 1 plus what? 6 times 2. Yeah, what? 6 plus what? So we're going to do what? 18 valence electron. That was step 1. Step 2, of course, sulfur will be what? The central atom. Then 2 oxygen will not be what? The side atom. So if you want to do that here we have sulfur, oxygen, and what? Oxygen. That was step 2. Step 3 says you will connect the side atom to the central atom with a single bond. So connected to what? A single bond here, right? So remember, this one have 2 electrons. This one have 2 electrons. So that is, I've used what? A total of what? 4 electrons. Out of what? My 18 electrons, right? So what will be the remaining electron? Remaining electron is going to do what? 18 minus what? 4, which is going to be what? 14 what? Electrons. 14 what? Electrons, right? Now which is going to be what I'm going to use what is step 4 and what step 5. You are not going to do that one first, so I'm going to pause here. Now let's try on that one. If you have something like this, NO3 what? Minus. So remember, my valence electron here have 5 times 1 plus what? 6 times what? 3. Remember, here we have my so going to be a plus what? 1. So it will be 5 plus what? 18 plus 1. I'm going to give me what? 20 what? 4 valence electron. 24 what? Valence what? Electron. Right? So remember, nitrogen will not be what? The central atom. So if nitrogen is the central atom, then 3 oxygen will not be what? Side atom. So it will be nitrogen, oxygen, oxygen. This was step 2. Step 3 says what? Connect the side atom to the central atom to what? A single bond. Right? Then calculate what the remaining electrons. Now, each of the bond have what? 2 electrons. It means that out of 24 electrons, I've used what? 6 electrons. So I'm not going to use what? I'm not going to calculate what? My remaining electron. So my remaining electron will be 24 minus what? 6. 24 minus 6, 24 minus 6. Here we have 18 valence electron. 18.